Next is Dr. Neil Leary. He's the director of the Dickinson College Center for Sustainability Education. Dr. Leary has been a participant in the science assessments of the Intergovernmental Panel on Climate Change since the 1990s and is a member of the IPCC's editorial board for the 2014 report. His research includes the design and effects of carbon taxes and cap-and-trade systems, but focuses on climate change impacts and adaptation in developing countries. He teaches courses on climate change, campus greenhouse gas reduction, and sustainable communities, and is the principal investigator for a NASA Global Climate Change Education project that partners Dickinson with other colleges to integrate climate literacy in the liberal arts. He received a PhD in natural resource economics from the University of Washington in 1988. Dr. Leary?
Thank you very much. It's a great pleasure to be here this evening. So I'll say a little bit about this group that Keith already mentioned, the IPCC, the Intergovernmental Panel on Climate Change, because I think there's confusion about who they are, what they are. You'll see some people describe it as these UN reports and these written by UN scientists. These reports are written by several hundred scientists who come from 70 countries around the world. The vast majority of them teach at universities and colleges or work for research institutions. Very few of them work for a UN agency of any kind. It's people like Richard Alley at Penn State University, and there are a number of folks within the state of Pennsylvania, scientists at some of our best schools who work on this. So that's important to understand right up front, that these, the reports that the IPCC writes, what they're doing is they looked at these 3 reports that came out over the last, a couple in the last month or so and one last September. They looked at about 30,000 publications that have been published in the peer-reviewed literature since about 2007. They're not reporting and assessing their own research. They're really looking comprehensively across everything that's out there and coming to some conclusions, assessing it, synthesizing it, trying to understand what it means. So these reports are not like one point of view. These are the judgments of several hundred scientists looking at it. It's the most comprehensive assessment of the science you'll find out there. So I think that's useful background to have. Now, getting to the heart of what I wanted to talk about. So in 2009, at the UN Framework Convention on Climate Change, this is this international meeting that Keith mentioned. At that meeting that happened in Copenhagen, the nations agreed on something. That's rare. They did agree on something. And one of the things they agreed on was that we should set a target to limit the amount that we would let the global climate, the world's climate, warm over this next century. And the limit that they agreed on was to say no more than 2 degrees centigrade. Okay? It's not binding, it's not something that we can be held accountable for, but this is sort of what we're working towards through this international negotiation process. The graph over on the left there shows from one of the IPCC groups their projections of how temperature will change. The one to focus on right now is the upper sort of reddish orange one. If we don't do anything different, if we keep on doing things as we are now, we're going to follow a path where it's going to warm by over 3 degrees and maybe closer to 6 degrees centigrade by the end of the century. Well beyond this target of 2 degrees centigrade. Okay? So that's an important thing to keep in mind. If we stay pat, we continue what we're doing, we're blowing right through that 2-degree target that we've agreed with other nations. The US agreed to this as well, okay? So don't forget that. We're on record supporting this. Not in a legally binding way, but aspirationally. Why 2 degrees? Okay, so the diagram on the right is from another IPCC report that came out about a month ago. And it shows, the basic idea here is showing how risks change with different levels of warming. So as you go to higher levels in that diagram, you're going from a half a degree warming to up to 5 degrees warming. And that coloration indicates how risks are changing. If it's white, it's kind of, not much going on there, a little bit yellow, something to worry about, orange, reds are things where something bad may be going on. So what kinds of bad things are we talking about? Really fundamental things. The availability of water. Okay, Joe already talked a bit about this, looking at drought situations in some parts of the world. It's going to vary depending on what part of the world you're talking about. Places in the dry tropics, subtropics, very likely will get drier. Those are the dry places already. These are places in, say, sub-Saharan Africa where they have a hard time feeding people. Okay? Other parts of the world, high northern latitudes in particular, more rain, it's going to be wetter. For some places, that's good. Other places are going to see so much more rain, and rain falling more in heavy events rather than nice light misting, but kind of what the southern U.S. saw today, torrential downpours. We'll see more of that kind of thing happening. Crop yields, okay? Crop yields, say for the next 20 years or so, the studies the IPCC looked at, all over the map where some places will increase, some places will decrease, some places not change much. As you go further into the future, meaning further up that thermometer towards higher warming, the places where there's going to be increased crop yields, there are fewer of them. More places are going to have decreases. Those places with decreases are going to see maybe at some point, particularly again sub-Saharan Africa, the most probably vulnerable area, 40–50% decreases in crop yields. Fundamentally just critical problem that we're facing on that. So that just gives you some sense of what, why sort of it's around this like between 1 and 2 degrees where things seem to be kind of tipping into like from serious impacts but to really troublesome worrying consequences. So next I want to talk about is this idea of, okay, if we're going to try and limit emissions to, or limit the temperature change to 2 degrees centigrade, that implies a budget for carbon, okay? The diagram on the far side there, that shows historically what greenhouse gas emissions have done going back to, I think, 1970s on the far left. You can't read the numbers on there. The basic idea is that we've seen steady increases, and this has been going on since the industrial era started. Regular, continual increases in greenhouse gas emissions, accelerating over the last, say, since 2000. So that's worrisome. We know it's a problem, and yet emissions are increasing, they're accelerating. So this idea of a carbon budget, okay? So far, since the industrial era began, we've put almost 1,900 billion tons of CO2 equivalent into the atmosphere, okay? It's been calculated that in order to stay below 2 degrees centigrade warming, that we have maybe about 1,800 billion tons of CO2 that we can put into the atmosphere. That's our budget, okay? That previous, so if we continue on so this path as we're currently on, sort of extrapolating from the graph there on the left, we'll be putting about 6,000 billion, so 6 trillion tons of CO2 into the atmosphere. That's 3.5 times that carbon budget. That means we're going to be going, if we follow that, we're going to go beyond 2 degrees warming. Within 30 years, we'll use up this budget, okay? So, what do we do about that? What do we need to do if we want to stay within a carbon budget of 1,800 billion tons? This shows in a very simple way, the diagram, where it's over on kind of the left side. So the kind of path we're currently following until about, in this case it shows this is an old diagram to 2015, and hoping that, okay, to get towards that budget, we'd have to follow that green path. Hopefully we're going to keep electric power here. We want to keep that coal burning stuff for a little while here. Burning coal for good purposes is okay. We got to find ways to burn less of it, but we don't have to be in the dark. So following that green band is kind of what we need to be doing, okay? That's a really dramatic change, okay? That's a fundamental change in what's going on from this process of continual growth to one of just bending that around, and we'd have to be looking at, say, 40 to 70% reduction in emissions by mid-century, all right? That means we have to change the way we produce and use energy. That means we need to change the way we grow food, the way we make goods, the way we design and build cities, the way we move ourselves and our goods from one place to another. These are fundamental things that are going to have to change. Can we do it? Is it feasible? In technical terms, yes. A number of different studies have looked at this. This particular scenario here that's depicted comes from Amory Lovins and the Rocky Mountain Institute, looking at one way in which we can get down to that carbon budget and try and stay within that 2 degree warming threshold. Some common features, this is a very particular one, but any of these sort of scenarios, some common things that you'll see in them. One is those sort of, I guess, be helpful for me to explain sort of how you read this. So on the far left side, okay, shows you how much energy we currently use. About 90 quadrillion BTUs, okay? Don't ask me what a quadrillion is like. I can tell you it's 10 to the 15th, but that's so big a number I can't. It's a lot of energy, okay? That's the total energy used in the US currently. If you go out to the top of the green line, that's sort of where the US Energy Information Agency says we're going to be if we don't have some changes. Those first, the green and blue, purple areas there, those are doing things to like drive down the projected energy demand through energy conservation, energy efficiency. That's a fundamental thing we need to do. Do as much of that as we possibly can, and that takes the pressure off what do we have to do with these other pieces of this strategy, okay? So we want to drive down demand as much as we can with very aggressive energy efficiency, energy conservation efforts. The other thing that's going on here is you'll see, so on the far left, you see oil and coal, fairly large as you come towards the right. All right, we're contracting those down. We're sort of phasing out coal and oil as you get later into mid-century. Okay, that's a fundamental thing that we're going to need to do if we're going to avoid warming of 2 degrees centigrade. Okay, natural gas. In this particular scenario, this is one Pennsylvanians will understand, if not love. In this case, natural gas being a transition fuel in this scenario, where we've got an expansion, an increase in natural gas, it causes less greenhouse gas emissions per unit of energy than coal and oil. So expanding that a bit, but eventually kind of narrowing that down as well. And then the yellow line there, the renewables being, we need to aggressively expand renewables. So those are some basic things that are common to a lot of these different scenarios. How do we make that happen? Joe's already laid out some different approaches to it. I think the main topic here tonight is this idea of using something called a carbon fee or a carbon tax. Basic idea here is it creates incentives, it provides a signal that all of us, whether we're running a business or a household, you figure out, I can save money, I can do better if I find ways, creative ways, to put less carbon into the atmosphere, doing these kinds of things. Okay, so that's the basic idea here. And if you do it through a carbon tax, it'll be less costly than a regulatory command and control process. Will there be economic cost to it? So technically it looks feasible, economically is it feasible? These are IPCC estimates where the numbers initially sound fairly large, that to do this, say by the year 2030, we might be giving up 1% to 4% of gross domestic product. This is globally. By 2050, it might be 2 to 6%. By the end of the century, 3 to 11%. Sounds like a lot. Well, what's going on here is those are out in the distant future. What's really happening is we're shaving a little bit off in order to have a less carbon-intensive economy and energy system. We're shaving off the growth rate by 0.04 percentage points or maybe 0.14 percentage points. And if you look at the difference of those lines, the top one's on the blue and the red one. So if we have if we're fortunate in the sense that we have 3% growth in GDP per year globally, 12 times the income in the year 2100 as we do now. Maybe that's good. We do this carbon fee thing, avoid 2-degree warming, and we're only at 11. Gee, what a sad world. Instead of 12 times today's income, it's 11 times. I think we can deal with that. Not sure we can deal with warming beyond 2 degrees centigrade. The other lines down lower show the same kind of an idea, but for a lower growth rate in the future. And I'm going to skip this because I know I'm running late, and I just want to show this one thing here. This is one of the impacts, results of Keith's story about Sputnik. Okay, this is federal R&D spending on non-defense kinds of things. Okay, the yellow bars going back from 1953, but that really sort of, it's like right around 1958. Okay, those yellow bars, that's R&D on space. Boom, Sputnik hits, space program, we're going to the moon. Okay, the green bars is energy. Well, there's a bit of growth sort of in the mid-70s, OPEC, and then what? Where's our space program for energy? That's something, so this is part of, we need a carbon fee, we also need an aggressive federal program on R&D towards energy, and also incentives for private R&D on energy. That those are things that are going to be fundamentally necessary for us to do what we need to. Thank you.